Okay, Dr. Pat here, and we're finishing off the third section here on domain and range of functions. Now we're getting into the challenging part. We're getting into the part we're talking about the symbolics, the formulas. How do we find domain and range of formulas? Okay, so let's just kind of recall that when we're doing domain, we're talking about the set of numbers, those numbers that we can plug into a formula. So that's kind of how I perceive it. Technically, it's the set of inputs, and then range is the set of outputs and stuff like that. But when I'm playing with a formula, it's really about me plugging a number into a function, and then the range is the results that we get. So that's the perspective that I use when looking at domain and range. Okay, now when looking at range, kind of just right here, this is the hard part. So I'm going to be honest with you. You got to know, you got to either look at the graph or you got to have some experience with that type of function to know what's going on with it. So that is really the hard part when we're playing domain and range with symbols. Okay, so now let's take a look at the process for domain. Now, when doing domain, I want to basically have this really inclusive, positive attitude that I'm going to start with assuming everybody. So this is kind of the perspective I'm going to have. I'm going to basically be saying I could use everybody from negative infinity to infinity unless you give me a reason not to. So I'm looking for reasons not to. I'm going to start with thinking that I can use everybody unless there's a reason. And there are three main reasons that we have early on when we're dealing with functions at the pre-calculus level. And so one of the reasons, of course, is zero in the denominator. Remember, if we've got a fraction, zeros are bad in the denominator. Dividing by zero is bad. Okay. The other one that we have are negatives in the even roots. Now that's square roots, that's the fourth root, sixth root, those kind of things. Odd roots are okay because you can have a negative and an odd root. It does get a real value solution. So it's only about being an even root that creates the problem. And then logarithms, they can't have a zero. They've got a domain issue. They can't be zero and it can't be negative. We get no values when we calculate the logarithm of zero or the log of a negative number. So I'm going to start off thinking I can use everybody unless I have reasons not to. Okay, and so then when we're playing with this, hopefully you're going to notice that in each of these things, what we're going to do is the actual calculation or the work we're going to do is we're going to try and find out when we're zero inside, what x value makes zero, and then we'll play the game of do we use the left side or the right side. Okay, so that's the attitude that we have. There's perspective. Let's go take a look at some examples. All right, so my first example right up here, the f function. Looks like we've got a sixth root. So right there, that little 6 right there, that means we've got an even root. So the restriction here is I cannot use anybody that makes negative inside there. So what I want to do is find out when this is 0. So off to the side, I just kind of take this and set it equal to 0. And then when I solve for x, let's see, I think that's going to be an 8/3. Okay, so 8/3 is a number that makes 0. And for a root, 0 is okay, so it's going to be an inclusive. But which side don't we want? In that number line kind of thing, here's 8/3. Do we want this side or do we want the other side, the right side? Because of this negative here, we want to use the left side here because that's going to create positive things for inside of us. So we're going to be using negative infinity to 8/3. Including the 8/3 because we're allowed to be 0 inside of a root. And again, you never get to use the never get to include the infinity. It's a state of being, and so we actually don't get that number itself. Okay, all right. So that's the example of domain with an even root. Now, when I'm looking over here at the k function over here, I want to start off thinking, okay, I could use everybody, but I'm noticing this fraction, and so this cannot be equal to 0. That's the one thing. We can be positive or negative. That's okay. Just can't be 0. So take that off to the side. I just kind of set that up equal to 0. Bring the 8 over and then divide by 2. I think I'm going to get 4. So x equals 4 is a bad number for us because that's going to make 0 in the denominator. But we're going to use everybody from negative infinity all the way to positive infinity. That's what I want to use. being optimistic. There's no other restrictions. And now I want to kick out 4 because 4 is bad for us. So I'm going to put a comma parentheses 4 here. That's going to kick it out with a union here, meaning that we can use this other side as well and do a 4 there. So I'm going from negative infinity to infinity, but kicking out that 4. We're going to just basically kick it all out, okay? So this notation is telling us what we're doing. Everybody but 4. Now when I go to the h function over here, I'm looking at this, I'm going, okay, x squared minus 3x plus 6. Let's see, there's no square root, even root in this thing. There's no fraction. There's no logarithm. Hey, there's no restriction on this one because there's not one of those 3 things that creates problems for us. No restrictions, so let's use negative infinity to infinity because there's no problems with that one. Now I'm over here at the g function. Oh, I notice this is an odd root. It's not an even root. It's not a square root, not a 4th root, 6th root that we did earlier. So that's meaning that there's no restrictions. So this is another no restriction. No problems here. No fractions. No even root. No logarithm. No restrictions. So we're going to use everybody. Don't have to kick anybody out. Okay, so that's what we got going there. And then, oh, I got another f function going on here. And so, oh, notice right here, boom. It's a log. It's a log base 15. Hey, the base 15 doesn't matter to me. It's all about logarithms. That means the inside here has to be positive, greater than 0, because you're not allowed to be 0. So technically that inside has to be the inequality greater than 0. So let's bring that 13 over by adding. Let's bring that 4 over by dividing. Don't have to change the inequality around because we're dividing by an a positive number. And so we're good to go. There is our answer there. If I put it in my notation here, the interval notation, let me see what I'm going to have. I'm going to start off with 13/4. I don't want it, can't use it, so I'm going to use a parentheses, and then we could use everybody bigger, and so that would go to infinity. So those are our examples of domains. Again, what I want to emphasize is this thing that I'm going to start with everybody and then eliminate all the things that make 0 in the denominators, make negative in the even roots, 0 and negative in the logarithm. So I want to start with everybody and then find when it doesn't work. And you noticed every time I was trying to work this, I was trying to find what made 0 inside. Okay, hopefully this helps. Talk to you later. Take care.